And we are live on Discovery Paranormal. Tan, 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 tan. You can use your imagination to see like little paranormal dancers coming out, a couple aliens and some ghosts and whatever, Bigfoot on the end, kicking up their little feet. Tan, 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 tan. Lights and lasers going off, man. Pa, 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 pa. But it has to be in your imagination because I could never afford to pay for it. So, something like that. But so this is what you got. This is what you got, right? So I want to talk about your reality, but also my reality and the reality of others and what our perception of reality is, and also Z, Zhuangzi, Taoist philosopher, right? Had a dream of a butterfly. He dreamt that he was a butterfly and that was his other life, and he was doing his butterfly things. And in fact, I'll give you the exact quote and what he said. He said, "Once upon a time, I, Shuang dreamt I was a butterfly fluttering hither and thither. To all intents and purposes, a butterfly. I was conscious only of my happiness as a butterfly, unaware that I was Chow. Soon I awoken. I'll say awoken. Soon I awoken, and there I was, veritably myself again. Now, do I not know whether I was then a man dreaming I was a butterfly, or whether I was now a butterfly dreaming I am a man. So, between a man and a butterfly, there is a distinction. But see, now in the world of the Tao, everything is related and everything is all together, and coevolution too, and all that on top of that. But this is more about your reality. So, is this dude a butterfly? Are we all butterflies dreaming that we are men, right? Dreaming about these things because, like, I don't know about you guys. A lot of my dreams, most of them, I I'll dream all night, and it's an ongoing saga. But I can't remember the bits and pieces. Only, let's say the larger chunks. This, that, and the other thing, and that detail. Sometimes waking up and even saying someone's name and writing it down, looking for the name online and whatever, because that's a good thing to do if you wake up saying someone's name that you've never heard of before. And yeah, your mind can make up all kinds of stuff. It is a great machine because it has absorbed a ton of material out there. Anything you see, anything you participate, you smell, touch, whatever, man, has all been recorded in your brain. Through those little bits and pieces, it can create anything that it wants. It beyond you, your consciousness, which you apparently don't have control over in your dreams, right? And that's an interesting thing because you would think that people can control themselves, their brains, what their brains do. So that's an interesting thing that we can kind of put on the side right now and get to that later, right? So the butterfly, I love it, man, because it shows that he was happy in that state. Number one, right? Number two, it brings you to the illusion of reality, right? And when I say this, I'm talking about the scientific proof that everything in energy and reality isn't real. So when I have these dreams of like these futuristic civilizations, and I'm going to use the term loosely because futuristic as to the technology currently in this world, which isn't really anything, because there are other civilizations that are well advanced, well more advanced, right? I don't know about less. I don't know about less. On this planet, we got people in loincloths and headhunters and cannibals and whatever. We still got that running around. You know what I mean? So not everybody is at the same level. So it's more very, very primitive world we are in, it, but is real. And sure, you could have civilizations from millions of years ago that are unbelievably advanced. It depends on their civilization and what they base their science on, what they base their technology on, right? So anyway, I'll read this to you, right? All right. What else can we do in the face of what scientists have discovered about reality? It's unbelievable, fantastic, and it's quite clearly showing that everything in is energy, and at most fundamental levels. Here's a really brief peek at the shocking things quantum physicists now know about our reality. So, of course, quantum physics. This is like a new world for us, right? Quantum tunneling, quantum computing. This is a new world. But once we harness the energy of that world, nothing is impossible, you know, especially reaching other worlds and not getting into some kind of so-called spaceship, but rather in some kind of vehicle that you can transport from one place to another. They're realizing all these things now about quantum let's say quantum reality, right? How's that? Albert Einstein: reality is merely an illusion, although a very persistent one. Eh? So okay, let's see. So facts that change everything we believe about life and self, standing it all on its head. Uh, did our view of the solar system all those centuries ago? Think about the learning of mankind and the things that we are discovering, the things that we're discovering just about our own neighborhood, let alone what's really out there, right? So if everybody in the world understood what the next few paragraphs outline about the energetic nature of reality, our planet would change overnight. In the early 20th century, the unquestioned assumption that the physical universe is actually physical led to a scientific search for the elementary point particle upon which all life is built, which would prove reality was not an illusion. And it also showed that people wanted to know the questioning, that constant questioning of mankind, which takes mankind to another level, questioning even what you do, your own actions, what your society does, their actions, constantly discriminating against what goes on in the world to try to change it and make it better, as it were. That not adding in like evil politicians and yeah, I mean, I'm talking about in a better world of what people can truly appreciate and accomplish, without these other stumbling blocks, which keeps us back. It keeps us back. All the political poison keeps us back, right? All right. So, but back in the day, as soon as scientists began smashing electrons and other particles in these, accelerators, Hadron Super Collider and others, right? They quickly realized the foundations of the physical world weren't physical; it was all energy. So, the evidence that everything is energy, the solar system. Picture of electrons and protons as tiny solid plant-like structures whizzing around a large interior neutron in an atom was all dead wrong. Electrons, muons, tauons, quarks, and gluons have no internal structure and no physical size, meaning that they are entirely illusionary, or put another way, made up energy, right? They are zero dimensional. Remember how even the Bible says we come from nothing. When I have Augie Nost on the show, who is a scientist, he says that we are nothing because we come from nothing and we are created from nothing. How's that? They are zero dimensional and more like events than things. Events. So, in the theory of a block universe, where everything is already set in stone and we're just living our lives, and every choice we make is already predetermined because it's either happened before or it was the planned things of going, it comes down to the events. And if it wasn't for time, it would all just be a bunch of like folders on your desktop. that you can just look at and click on, but their time kind of puts everything in order, a functional flow of information, right? Like taking like a movie, you have all your little bits and pieces and all your little photos and all the stuff you put in there, and then you put it in motion, right? It's time. So, all right, let me get past all of this. All right, so getting back to wave particles, electrons showed up in one form or the other depending on the experiment involved. They were also hard to pin down. After all, when everything is energy, it's hard to keep in one place. Scientists can know a particle's velocity or its position, but not both at the same time, which is like a cop clocking a car going 150 miles an hour on the interstate but not being able to locate it to give chase. Wouldn't that be awesome? Just kind of zoom right the hell down the road, man. Ain't nothing stopping you. But boom, get out of the way. I'm a quark. God damn it. Yeah, electrons coming. Cops like, he's going 250 miles an hour. But I didn't see anything though. That's right. That's right. Anyway, let me get it. I'm sorry. All right. So another strange habit that energetic particles have is that they could be in more than one place at one same time, called a superposition. Right? Electrons and other hey, if you're a parent, you know exactly what that means. Electrons and other non-particle particles are capable of being in hundreds of places simultaneously, which is only possible if everything is energy at the most fundamental levels. It seems like the more physicists discover, the worse things get for those who, try to make any kind of sense of it. You know what I mean? Because if you go by this information, all right. Anyway, all right. Let's say, in fact, towards the end of his life, when Einstein was asked what the biggest physics question he wished could be answered before he died, he replied, "I'd be happy if I just knew what an electron really was." There you go. Now we know, and we know it is energy at the fundamental levels. He's an electron, right? Reality is stranger than we think. It's stranger than most people can think. And the reality that everything is energy and energy is everything. Scientists have been dealing with the shocking implications of quantum theory for 100 years now. But as far more as mainstream society is concerned, scientists are stupefied still on the conclusions that life may as well not exist. I'll read that again. They came upon the conclusion that life may as well not exist. So, what is life? Why are we here? You say you're here to love. I love coffee. I've accomplished that. Do I get a ding ding? Do I get a gold star? I've loved and lost. I lost my mom. I've lost my beautiful pets too. You know, so what more is there except loss? It seems like, but all these things are so they're electrons, so they got a zero, nothing, and we're all made up of that, which makes us that. It's crazy, It really is. It really is. Because when you start thinking in those terms, you start thinking of other things, and why are we so restricted to this planet? Why can't we hop from one universe to another, or one dimension to another easily? Why? Because we're humans and we're stupid and we don't have anything that, I mean, you're still killing each other with guns and all this crazy stuff is going on. We don't have the responsibility to have that kind of power. Imagine if we went to other worlds. That's like an infectious disease traveling around. You know, you don't want some other universe to get human herpes, do you? So, but there's a handful of people that aren't like that. But but take those same people and put them in certain situations, give them access to certain technologies that we don't have, that are way unbelievable and more powerful. Would those same people be as neutral, or as good, or as nice, or as kind, or as selfless, or would they go the other direction? Money corrupts. A society built on monetary funds, on you have to have this, and this person next to you can have more, so they have more, and then you see what they have, and they see that you have less, and they start treating you different than the other people. This happens in our society, and it's really unfortunate, that it happens like that. But it's like that for a reason, to keep people in a certain place and not have everybody blossom, as it were. Right? All right, for whatever reason, it was certainly by design. This didn't just happen by accident. You can't have these intricate systems like that, even the human brain, by accident. Or developed by nature over time. Really, that's a far stretch. It really is. So anyway, so we know about quantum physics, right? And let's see. How about the Matrix? The Copenhagen interpretation. So let me go back. All right, let me get this from the beginning. So this goes back to the movie The Matrix, right? So, and there was so the Copenhagen interpretation, wave function of particles, and you want to take these things to logical conclusions, right? The Copenhagen interpretation of quantum mechanics seems to imply that reality, the world as we know it, can only take place in some sort of measurement or observation that takes place on the macro level of existence, the level where scientists and all of us more ordinary numbskull types of just living and operating, right? It means that not only is everything energy, it responds to consciousness itself. This is deep stuff, man. If you sit there and think about these things, like not just like listen to the show, but I'm after the show, I want you guys to go on and research this, right? And it's just such a deep way of thinking of like, wow. And you would think that if this is true, you would think that if it's all made up of light and all this other stuff, and boom, that we would have a better control over our flesh and bone bodies, over the diseases and viruses and terrible things that can happen, or the terrible accidents. You would think that people would be more impervious. So people are actually really frail, and these other things can come in from left field that can affect us and take us out. But that energy doesn't die; it moves on, right? From what I understand. So, in other words, let's say this: it's possible that unless some agency, such as human consciousness, interferes, particles remain in a probability type of energy wave state and never actualize into one location particle form at all, right? So ultimately, reality we experience, it seems to be the result of human consciousness interfacing with a quantum level of existence that are pure waves of energy. So the air that you're breathing, do you think you're breathing? Like Morpheus in that movie, right? He would ask Neo, in their martial arts sparring scene, The Matrix. I've actually never seen that movie. Like I've seen chunks of it. Like it's it's like a dream. I say this bits and pieces of it, so I can kind of piece it together what it really has. It's not really my kind of thing. I don't like movies that glorify violence, and I know it's as hard to get away from that. To get away from companies that put sugar in their food. I'm trying to get sugar out of my life, and oh my god, damn man, talk about every little tiny flake. You know what I mean? But yeah. So he says, Do you think you're breathing the air?" I'll say it like that, dude. Do you think the air you're breathing is real? And Neo's like, huh? He's like, think again. Morpheus is trying to get across to Neo that everything he thinks in is real. In actuality, is only information that the brain receives and translates into a place called reality. In that place, you're going to feel those senses. You're going to feel like you're touching something hard. You're going to feel like you're driving a car. You're going to feel like you're eating a steak. But in reality, these are all just impulses and electronic impulses and senses that are sent to your brain. So you could be some battery right now, like in the Matrix, like, some human battery powering some computer that's called the Zuckerberg computer. You know what I mean? so, so now scientists are thinking the same way, understanding that energy is everything and energy is information. I used to think about this stuff when I was a kid at the beach. I'd be at Long Beach, Long Island, growing up, and the beach, ocean's an amazing place, man. It's where life begins, basically. You know, if you think in those terms, I've seen whales' tails come up and slap the water. That's cool. If you go all the way out on Long Island, there's seals out there and great white sharks. There's great white sharks like everywhere. You know what I mean? Kind of just that tiger sharks. People act like great white sharks is the beat all, beat all. Let me tell you, man, you don't want to bump into a tiger shark or any of those other ones either. No fish with teeth. How's that? How's that? Yeah, we're delicate humans. We cut easily. So no fish with teeth. I don't want to mess with that. You know what I mean? So the Copenhagen interpretation isn't the only indicator that the information based matrix of energy reality is what we're dealing with. Entanglement is another freaky physics conundrum pointing that way. Once particles have interacted, they become entangled, which means forever after they affect each other's spin, which really isn't a spinning motion at all, but something called the angular momentum. Ooh, I like that. Angular. I'm going to change my name to Angular Momentum. That's going to be my new radio name. Angular Momentum with you. Yeah. They are connected by an unseen energy of force that permeates everything. So, what is that? What is that? You know what that is? That gets us into the world of matter, dark energy, all of that stuff. Antimatter. Oh, there's a whole bunch of antimatter. They collect antimatter in these super colliders. They collect little bits and pieces of it. They say that if you had, let's say, a nickel, like a nickel like change in your pocket, the size of that of antimatter, you'd be able to use that energy to launch the space shuttle in the air like 30 times. That's how powerful. They have to suspend it magnetically because if antimatter touches matter, there's a problem there. There's a little explosion. And then it doesn't last in that state either. So it's fascinating stuff. It really is. This ain't no sci-fi channel, man. This is the real deal. So basically, all of this either means we ignore Einstein's theory of special relativity and its prohibition against faster than light travel for an information bearing signal, and accept the particles are somehow breaking the speed limit and communicating instantaneously across vast distances of everything is energy and somehow connected to a subatomic level. So this is the conversation I had with my old neighbor up in Ithaca, who was head of the vet school for Cornell for a number of years. So we're at a block party, and he and I start talking. We're kind of the outcasts, you could tell. He looked like the wacky scientist, and I look like the dark, disturbed assassin type of guy. You wonder why he's at the party. Security, security. So he and I started talking, and I had just gotten into a whole thing about tachyons with the kids. My ex's kids got them Chinese lessons, and their Chinese teacher was a Cornell grad student who was a physicist. And I mentioned tachyons to her, and she laughed in my fat face like I was some idiot. Like, ha 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 ha! You're so stupid! Bah! She actually did laugh in my face. I wasn't fat, but she laughed in my face, my fat face. Ha ha ha! No such things as tachyon. And I said, if you don't have the mind to think outside the box, you're never going to get anywhere in science. I mean, if you're a physicist, the very world that you're entering now is quantum physics. And Cornell, they're really either first in science or second or third somewhere. When I first moved to Ithaca 25 years ago, they had just, I think that year invented the nanobot motor. That's 25 years ago. Now they have a whole nanotech department and the whole bit. So yeah, science happens, especially when you work hard on it, especially when you get grants from military and anybody else to work hard on that science. But then I'm at the party and I just wrote the girl off as ignorant. I'm at the party, meet this dude, Alex, and we start talking. It's, I don't know. We start talking. You know what? We start talking about science. I don't know even know how. It was just something that came up, and then I mentioned the word tachyons. This dude stomped his feet and clapped his hands and laughed so hard. And he's like, I love it. He's like, I never thought I was going to come to a block party and talk to somebody about tachyons. And we had an awesome conversation about tachyons and the probability of and all that. And, not too far around there, Miss Ha 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 in your face, no such thing as subatomic particles that travel at faster than the speed of light. Well, they came about neutrinos, and what are neutrinos? And then just because people don't understand things doesn't mean they don't exist. Just because we don't have the science or the technology to detect things doesn't mean they aren't there. You know, so that's the world of quantum physics. All the work they're doing now, and especially in the last few years, quantum physics, it just brings them to more questions, and I love it, man. I love it. So we're made from nothing. And Alex and I had a great conversation about tachyons. And so if you think in terms of the speed of light, radio waves travel at the speed of light. Light travels at the speed of light, obviously. Tachyons, subatomic particles, penetrate the speed of light, penetrate our reality. So supposedly there's lots of these around us all the time, flying straight through, right? And that's what we've got. So, which leads us to the expansion of the universe. You know what I mean? So, all right, here we go. A cosmic expansion. The universe could stop expanding remarkably soon, a study says. So, in just 100 million years, the universe could start to shrink. 100 million years. You pack your bags. But they'll be unpacked, of course, if the universe starts to shrink. So, and this is scientific research, right? The naysayers who don't believe in anything paranormal, God forbid, are talking like this. So, after nearly a 13.8 billion year expansion, a nonstop expansion, universe could soon grind to a standstill and then slowly start to contract. New research published in the journal Proceedings of the National Academy of Sciences suggest. So, in the paper, three scientists attempted to model the nature of dark energy, a mysterious force that seems to be causing the universe to expand ever faster. It's accelerating, yes. Based on past observations of cosmic expansion, okay, in the team's model, dark energy is not a constant force of nature, but an entity called quintessence, which can decay over time. The researchers found that even though the expansion of the universe has been accelerated for billions of years, the repellent force of the dark energy may be weakening. According to their model, the acceleration of the universe could rapidly end within the next 65 million years than within 100 million years. But if you think in terms of the billions and billions of years, this is really too far down the road for that expansion to start contracting. You know what I mean? The universe could stop expanding altogether, and instead it could enter an area of slow contraction that ends billions of years from now. With the death or perhaps rebirth of time and space. Time and space. So these guys are putting time as a localized thing. We're talking about this universe and not other universes, because most scientists will agree that there's the multiverse out there. So one wouldn't necessarily affect the other, or maybe it would. Depends on the density, black holes, things like that. Or does it expand and contract, and does time go backwards? Because there are a lot of people that theorize that at that point, time will then run backwards, and you have to unlive your life. Imagine that. Ugh, gotta go through puberty again, backwards. Oh my God, my God. At least I'll see all my pets again and family. So imagine all the wars that will all the people will jump up to life. You know what I mean? All the guns, all the bullets will go back into guns. Everybody comes alive again and start, back to what they were doing before these terrible events hit them. Lottery winners losing all that money, or really never having it to begin with. If let's say, all right. So going back in time, 65 million years, that's when the Chicxulub asteroid hit the Earth and eliminated the dinosaurs, supposedly. Supposedly, right? They don't know. They really don't know. They have an idea. So on a cosmic scale, 65 million years is remarkably short. That make you feel good about your age? You know what I mean? Feel pretty young, even if you're over 50. Nothing about this theory is controversial or implausible. Gary Hinshaw, a professor of physics and astronomy at the University of British Columbia, who was not involved in the study, told Live Science. However, because the model hinges on past observations of expansion alone, and because the present nature of dark energy in the universe is such a mystery, the predictions in this paper are currently impossible to test. For now, they can only remain theories. But you have to see theory is a very important part of science, and it allows you to move in that direction. It's the reality of the unreality of reality of your reality to move forward into reality. You know. So yeah, the energy of the void, in martial arts, so let's say Taoism, actually, we refer to the void as the void. Like life is having to leave home and death is going home, you know. And then in the original story, there was the void and there was the absolute, and the absolute is like a god or whatever, but not really, they never really put a person on it. And the absolute questioned its own existence. It questioned its own reality. And when it did that, that's when the Big Bang happened and the universe exploded. And then the yin and yang formed and all this other stuff. And it's really cool to get into that kind of history, you know, just interesting. So anyway, so, since the 1990s, scientists have understood that the expansion of the universe is speeding up. The space between galaxies is widening faster now than it was billions of years ago. Scientists named the mysterious source of this acceleration dark energy. It's invisible, an entity that seems to work contrary to gravity, pushing the universe's most massive objects farther apart rather than drawing them together through dark energy, though dark energy makes up approximately 70% of the total mass energy of the universe, its properties remain a total mystery. A popular theory introduced by Albert Einstein is that dark energy is a cosmological constant, an unchanging form of energy that's woven into the fabric of space and time. So, if that's the case, and the force exerted by energy can never change, then the universe should continue expanding and accelerating forever. If you think so, let me ask you this: what's it expanding into? You know what I mean? Like, if you only got so much space, you can only put so much stuff in there. You know, and as something expands, something also has to give for that expansion. Or it's just dead space, and then what is that dead space? So okay. A competing theory suggests that dark energy doesn't need to be constant in order to fit within observations of past cosmic expansion. Rather, dark energy may be something called quintessence, which we talked about before, a dynamic field that changes over time. Anyway, so we know about dark energy, right? And we know that people don't know what it is. You know what I'm saying? Isn't that the weird part of it? Like, just it must be really cool to collect huge grant money on something that doesn't exist, or technically speaking, that money doesn't exist, right? Although you need it, or you're going to eat, or have a place to sleep, you know. So, but the reality is, it's I've always been I know scientists, dated one. I know a bunch of them, people who work in the scientific field and different stuff, you know, and they get this great grant money, and then some of them work on things that are usable, and some of them work on just the theory part of it. And man, what a life, you know, kicking up your feet, having your iced coffee, just theorizing shit all day, all day. I'm going to study how many bananas a monkey eats in 24 hours. Then I'm going to study how many they eat in 12 hours. Then I'm going to study how many they eat in 1 hour. And then I'm going to go by the holiday if it makes difference. Like, oh, here's $1 million to study that. Thanks. Thank you. That really is exactly how it is. I'm not going to tell you my scientist story because I should, because it's cute, and at some point I'm going to be dead and nobody will care. So I will tell you the story. It's my show. Are you guys ready? You get your coffee. So I was dating this girl from France, except she was in Ithaca. She was a scientist working, not working for Cornell, but using their labs because they had a nuclear, reactor up there, and she needed it for the stuff that she did. So we're dating, and you know, she spent half her time in the lab, the other part of the time with me. Right. This went on for a little while, and I actually felt kind of guilty. I was taking her away from her work because she was working on RNA, like ribonucleic acid, and trying to figure out ways of getting rid of hereditary diseases in families. I didn't want to stand in the way of someone's diabetes, like, or whatever, man, or cancer, that type of stuff. But we were dating, doing our thing. Had a lot of like silly arguments, man. French. They don't like they don't like the whole thing. The French have some kind of deep hatred for America. They really do. No matter how nice they come off, and they don't really come off as nice. But it was like that. But she was actually from the northern areas of France, and came from a really cool, normal old family. But anyway, there was a time that she told me that the scientific field is very competitive, and people are always trying to steal your ideas. They try to pick your brain, and whatever you're working on, they'll take it because, one, they want the big prize. They want the research. They want to get published. Getting published is a big deal to them. That's kind of like their only deal, is to get published, because that's how they get more grant money. That's how they get more action, right? So then she has to go down to Long Island with these other three scientists. And let me tell you, these guys, if you met them, these are the biggest brains in the world. They wouldn't be able to find their way out of a building that had a huge sign that says exit with an arrow pointing at it. There's no real common sense. And then they had to go down to this thing on Long Island. They had their little big scientific convention. All these scientists from around the world going to North Shore of Long Island. Like, there's this big facility there, and what is it? Cold Spring Harbor. They have like a big thing there. Right? So there was no like GPS in those days. This is how long ago it was. GPS was like a new thing that people really didn't have. Some did, some didn't, but very few and far between, as opposed to now, right? So she's driving down in her Volvo, going in with these guys, and then she calls me because, like, she calls me like crying. I'm like, what's going on? And she's like, we can't find our way over the George Washington Bridge. I'm like, what do you mean? Because if you cross the bridge from the west side, it tells you you're going like north. And if you cross from the other side, it tells you you're going south, but you're going east and west. It's actually really confusing. If you don't know your way through there, you can get lost, and you don't want to get lost in that neighborhood. You don't want to get off that highway. You want to get through there as fast as possible, and maybe have body armor. Get through there. Yeah. So, or if you could have like some Espanol, got something going on. That's Spanish Harlem, man. That's like the Bronx and South Bronx. That's like where all the gates of hell come together. It really is. So anyway, I'm like, okay. They went over the bridge 7 times. So I said, you got to go by another time. Turn around. Turn around, go back. And I was their GPS until they got to Long Island, you know? And so then she calls me from the party later on that night. All these guys drinking champagne, whatever they do, those parties. I've been to those parties, not those parties. I've been to like fashion parties and club parties, not not scientific. Nobody's ever invited me to a scientific type of dealies. So she calls me from the thing, and she's a little trashed on champagne, whatever. And and just before she gets off the phone, she's like, I love you. Which is very, very sweet. And so then people in the background, these guys are like, who's on phone? Who's on? Because these guys, like scientists from Sweden and all these other people around, who's on the phone? And she's like, oh, it's my boyfriend, Michael. Oh, and they're like, hello, Michael. I'm sitting there laughing, man. I'm like, and she's like, I love you. They're like, we love you, Michael. We love you. They all start singing, we love Michael. Oh my God. I was like rolling, man. And I'm like, who are those guys? And she's like, just the leading minds in science around the world. I'm like, thank you. Check, please. Luckily, she didn't have to drive home. You know what I mean? But now, this is important because after, like the day after, after she came back the next day, she said that the guy that headed off the whole thing, that invited all these scientists, he like got everybody drunk and went around asking them specific questions about the experiments that they're doing and writing it down. And she felt like really weird that she had said more than she should have. And man, that's when you have to think like that, because that's how competitive it is. They don't want to do their own work. They want to hop on somebody else's work and then, pick it up there and finish it, or collaborate or continue it. But even though they themselves have no original ideas, right? Anyway, what the hell was I? So okay, away from my silly stories. But all right, expecting objects to have their own independent existence, independent of us and also other objects, is actually a deeper seated assumption that we make about the world. This assumption has its origin in the scientific revolution of the 17th century and is part of what we call the mechanistic worldview. According to this view, the world is like a giant clockwork machine whose parts are governed by the set and laws of motion. This view of the world is responsible for much of our scientific advancement since the 17th century. But as Italian physicist Carlo Rovelli argues in his new book, Hegloland, quantum theory, the physical theory that describes the universe as the smallest scales, almost certainly shows the world view to be false. Instead, Rovelli argues that we should adopt a relational worldview. Right. So, what does it mean to be relational? During the scientific revolution, the English professor pioneer Isaac Newton and his German counterpart Gottfried Leibniz agreed that the nature of space and time. They disagreed on the nature of space and time. Newton claimed that space and time acted like a container for the contents of the universe. That is, if we could remove the contents of the universe, all the planets, stars, and galaxies, we would be left with empty space and time. This is the absolute view of space and time. Leibniz, on the other hand, claimed that space and time were nothing more than the sum total of distances and durations between all objects and events of the world. If we removed all the contents of the universe, we would remove space and time also. This is the relational view of space and time. They are only the spatial and temporal relations between objects and events. The relational view of space and time was a key inspiration for Einstein, which when he developed general relativity. So these guys are like the dudes who one guy has the peanut butter, the other guy has the chocolate bar, and they're all happy unto themselves eating what they got. Then they kind of clash and get it together, and it's a whole different world, man. And Einstein, you're talking about old science. stuff that these guys were just they weren't the beat all biggest brains at the time they were, but we have gotten to different places in science that's gone beyond of what these other people had surmised, right? But it's happened because of their work. So they are stepping stones to this technology, right? So Ravelli makes use of the idea to understand quantum mechanics. He claims the objects of quantum theory, such as photon, electron, or other fundamental particles, are nothing more than the properties they exhibit when interacting with, in relation to, other objects. We make it real. We make each other real, but it's got to be generated by something, right? So these properties of a quantum object are determined through experiment and includes things like the object's position, momentum, and energy. Together, they make up object state. But is there momentum? Is there anything? I mean, does it travel? Is it all just moving around? How do we know it's traveling around? Because we're observing it, and the fact that we're observing it, doesn't that change the whole goddamn thing to begin with? I've read, you know. So okay. Just like Schrodinger's cat, man, You put a cat in a box with a lethal agent. It's really terrible, man. How about a cat? I don't know a cat, a politician with a lethal agent like a veil of poison gas triggered by a quantum process, like the decay of radioactive a radioactive atom. We close the lid. The quantum process is the chance event. There is no way to predict it, but we can describe in a way that tells us the different chances of the atom decaying or not in the same period of time, because the decay will trigger the opening of the vial of poison, and then hence the death of the politician. The politician's life or death is also purely chance event. So, according to the orthodox quantum theory, the politician is neither dead nor alive until we open the box and observe the system. The puzzle remains concerning what it would be like exactly to be neither dead or alive. So, yeah, it's an interesting story. I don't like it. It's got a cat in there, and you don't mess with a cat. You know what I mean? To me, people. So it comes down to this: we don't know anything, and we are learning, but it's little bits and pieces. You know, when it comes to quantum tunneling, right? Let's say I established 2 points of quantum tunneling on the Earth. 2 points of 1 point of origin, 1 point of receiving. And let's say I had a pencil, plain old number two pencil, and I held it in my left hand. And now that pencil, because of an arc that I set in predisposed point out in space, the pencil goes all the way out in space instantaneously. There's no time. These particles that they've moved around are connected. Even when they turn one particle clockwise, the other one turns counterclockwise. It could be hundreds of miles away from each other. That these particles they have divided. They have proven the connectivity, the connection between these things, no matter how far or what's in between. Or how much time? There's no time when it comes to that. It's instantaneous. So imagine if you have that way of instantaneously being able to connect. All right, let's say you want to travel to Uranus. You know what I mean? You may not think it's a very far journey, but it can be. If you wanted to, and you took that pencil in your left hand and it went all the way up to Uranus, and then it arced and it came back, and then you held it in your right hand, you're actually able to write with it. And then at point, you are connected to all those things plus Uranus. If you had some kind of device, you'd be able to get there. You'd be able to teleport there. You wouldn't have to go there in real time in some spacecraft and take millions of years to get somewhere, or hundreds of years, or even months. You'd be able to do it instantaneously. That's the deal, right? But what does that tell us about reality? We know that everything in reality is smoke and mirrors, basically, is what's presented to us, right? Isn't that basically what it is? So, basically, right? All right. So, last but not least, the multiverse. Right? Multiverse theory suggests that our universe, with all of its hundreds of billions of galaxies and almost countless stars spanning tens of billions of light years, may not be the only one. Instead, there may be an entirely different universe distantly separated from ours, and another and another. Indeed, there may be an infinity of universes, right? All of their laws of physics, they got their own laws of physics, they got their own collection of stars, galaxies, all that. So the physics for them could be different from the physics for us, or maybe it's not. Maybe it's on the same plane when it comes to quantum physics. And I also have a theory that there's a mega world of physics. I don't just think it goes from the micro level to the macro level. I think it goes further and further down and up. I think that it's a chain, a never-ending chain, or a Ouroboros, right? Something that this mythological creature, like a dragon, looks like, and eating itself, and it goes on and on and on, and twisting, twisting, twisting around. So if you had multiple universes, let's say you had multiple dimensions, right? And you have one dimension where the Earth is expanding, but no, the next dimension, the Earth is everything. The universe is expanding, the universe is contracting, everything happening in an opposite way, and the next one is expanding, the next one is contracting. This breathing back and forth, up and down, back and forth, something like that. That makes more more sense to me. It really does. So anyway, the biggest piece of evidence that the multiverse is that life actually exists is particularly intelligent life capable of making cosmological observations. You know what I mean? The traveling around the universe. Certain aspects of our universe seem special and important for supporting life, such as the longevity of a star, the abundance of carbon, the availability of light for photosynthesis, and the stability of complex nuclei. So, you know, all these features are typically not the case you get when you look at the your planets out there. So the Earth stands out as a place. It also supports the life that's here, but the life that's here was developed here on the conditions that exist, right? So I don't know. We could talk about this for months, for months, man. It's never ending, and I hope you got a good chunk of it tonight. It if you truly can make your own reality, and if it's all built on nothing, and you can make your own reality, then all you really have to do is think positive in those terms and push the negativity away and take in the good stuff and think positive and think about the life that you want around you rather than the one you got, unless your life is perfect and don't change anything. But I think that we can use this to make us better people, right? And also in the next life and the next life and the next life, even if you're a butterfly flopping its little wings, or if you're a big fat cat laying there in the sunshine all happy because you ate a bunch of treats, that's where I'm going. That's gonna be my existence. Big fat cat there with a cat lady, crazy cat lady, man. Big fat cat laying in the sunshine, eating some treats. What you got for me? Oh, a little piece of steak? I'm happy for that. So, anyway, I will see you guys on the next Discovery Paranormal. I hope you had a good time. Watch out for that dark energy that nobody seems to know anything about. And do your research, man. All the stuff we talked about is so interesting to read. Oh, so interesting even to watch videos that are online. And, like legitimate videos, not the crap that people put out there, but legitimate information, people who really did their research. Amazing, cool stuff. I'll see you guys next week on UnitedPublicRadioNetwork.com, y'all. Adios, muchachos.